Go ahead and split your notebook into 6 sections with trig functions and right triangles as your title. Hello everyone, welcome back to our series on pre-calculus review. Today we're going to be going over trig functions and right triangles, which are extremely important in calculus. So the first thing I need you all to be able to do is to be able to label your sides. Okay, so when we're labeling sides, you're going to be given an angle like theta or alpha or beta or, I don't know, what's another one? Phi. These are all Greek letters, or you can be given a capital letter. And you need to be able to label your sides, okay? So the first thing you need to do is find your 90-degree corner, okay? And across from 90 degrees is always your hypotenuse, okay? So across from this 90, hypotenuse. Across from this 90, hypotenuse. Across from your 90, hypotenuse. One more time. Across from your 90 is your hypotenuse, okay? Now, next important thing. Across from your angle, regardless of where the angle is, the angle that they tell you is your reference angle, on the other side is the opposite side. So over here, my angle's on this side. Opposite would be here. My angle is here. Opposite is there. And lastly, across from this angle, this side would be my opposite. So as you can see, the hypotenuse relatively stays the same, but the opposite side changes depending on what your angle is, okay? So now my last side, whatever's left over, is your adjacent. So that leftover side, I'm going to go in and label it as adjacent, okay? So you need to be really good at labeling your sides. If you don't label your sides correctly, the whole problem is wrong. So you have to be really good at finding the hypotenuse, find the opposite across from your angle, and then that leftover side is adjacent. Okay. So I have one example here. We're going to do it together. And these two problems are going to be different because they have different angles. Okay. So in my first example of sine of B, they tell you that your angle is B. Okay. So this is the reference angle. This is your important angle. Now, here's my 90 degrees. Across from 90 is hypotenuse. Okay. Now, in this problem for sine of B, across from B, across from your angle is opposite. And that leftover side is adjacent. Okay. Now, to find the sine, if you recall from pre-cal, I can use SOHCAHTOA to find the sine. And sine is opposite over the hypotenuse. Okay. So in this problem, my opposite is, how much is my opposite? My opposite is 4, and my hypotenuse is 5. So I don't need to simplify or rationalize, so my answer is 4 over 5. Now, for the next problem, they tell you that your angle is A. It's no longer B, it's A. So that means you need to erase all of these labels. And we need to create new labels because now my reference angle is A. So I circle A. The hypotenuse still stays the same because 90 doesn't change. But across from A, this side is now opposite for this problem. And the leftover side is adjacent. Now, for tangent according to SOHCAHTOA, is opposite over the adjacent. So, opposite over adjacent, my opposite side for this problem is 3, and my adjacent is 4. So, opposite 3 over adjacent 4, my answer is 3 over 4. So, if you notice, I have very different labels depending on what my angle is. So, you need to be very careful when labeling your triangles. Okay. Now, Special right triangles are going to come up time and time again, and you need to have them memorized. Looking at this triangle in orange, the perfect corner is 90 degrees. The smaller angle that's more acute is 30, and then this one would be 60. Okay. Now, between 60 and 90, between these two sides, I have the value of 1. Between 30 and 90, this value is radical 3. And lastly, the hypotenuse is 2. For a 45 degree triangle, because these two angles are both 45, this is an isosceles triangle. And an isosceles triangle, these two sides are equal. And for this example, for this 45, 90 triangle, those two sides are equal to radical 2. And I'm going to remove this line because I don't want you guys to think it's a negative. So I have radical 2, and 2. You need to have these values memorized for a 30, 60, 90 triangle and a 45, 90. Now, a reference triangle is created by connecting the terminal side of an angle to the positive x-axis. So if you remember from my previous videos, this is the initial side, and here is the terminal side. So if I wanted to create a triangle, a reference triangle, I would need to, it says, connect the terminal side to the positive x-axis. So here's my terminal side. Remember that this is a positive x-axis. So to create the triangle, I connect the terminal with the positive x-axis, and it creates a triangle. Okay? And then we would be able to determine what this reference triangle angle is depending on the location of the triangle. So in this case, I know that this triangle is cutting my 90 degrees perfectly in half. So this inner angle would be 45 degrees. But it's because this would change depending on, where you are on the axis. If my terminal side landed over here, I would connect to the positive x-axis and it would create a triangle in this orientation. Do you see that? If my terminal side landed down here, same thing. I would go upward to connect to the positive x-axis, and this would be my triangle. And lastly, let's say I landed here. I would connect upward to the positive x-axis, and this would be my triangle. Okay, so the triangle is all going to depend on wherever your angle lands. Okay, so we're going to be creating the reference triangle of 120 degrees. So I start by graphing 120 degrees, which would be 90 degrees, and then an additional 30 degrees. Okay, and this here should say 30 degrees. Okay, so there is my terminal side, and then to create the reference triangle, I'm going to connect this terminal side to the x-axis, and it creates a triangle with the x-axis. Now, remember that if I just traveled 30 degrees, and in total this is 90 degrees, that means that this internal angle right here, to complete the 90 degrees, would need to be 60, which means I have a 30, 60, 90 triangle, and I put the values of my 30, 60, 90 triangle in here. Okay? And this would be my reference triangle. However, you need to be really careful because now that I'm on the X, Y axis, I need to consider and contextualize where I am. So right now, I'm in the second quadrant, okay? Meaning that if I have X values, they go to the left of the x-axis. And I know when I'm to the left of 0 on the x-axis, my values are negative. So this value here of 1 needs to become a negative 1. Okay, be really careful. Now, when I'm on the second quadrant, I go upward on the y-axis. And going up on the y-axis means that I have a positive y value. So I'm good here. And your hypotenuse is always positive. So having a positive 2 works. Moving on, I'm going to be creating 2 reference triangles for 225 and 330. So first things first, we graph our angles. I'm going to travel at least 180 for 225. So here is 180 degrees. And then I need an additional 45 degrees. So this here would be my terminal side. And to create my reference triangle, I connect the terminal to the x-axis, creating my triangle. And you kind of have to like take different approaches to try to figure out what that internal angle is. But looking at this problem, after I graphed 180, I had to travel a total of 45 degrees afterwards. So this internal angle needs to be 45 degrees. And that means I have a 45, 45, 90. So I put in the values of my 45, 45, 90, right? The hypotenuse is always positive, and then I need to contextualize where am I on the xy axis. So I had to go to the negative side of the x-axis. So this value becomes negative. And then I had to go downward on the y-axis, which means I have a negative y value. So I'm left with negative radical 2, and positive 2 as my sides for this angle. Moving on to 330. 330, I would graph this. For sure, I could do 180 here, meaning I'm left with 150. So let me first graph 180 in the positive direction. And then I could do another 90 degrees, leaving me with 60 degrees finally to travel, which would be 2/3 of these sections, okay? And so now that I have my terminal side, I'm going to connect this terminal side to the x-axis, creating my reference triangle. And again, I'm going to use a different approach. Remember that I traveled 60 here, and in total I have 90, meaning that this corner would need to be, to get 90, from 60 to 90, I need 30. So this becomes a 30, 60, 90, where my sides are 1, radical 3, and 2. And then you kind of have to, again, contextualize. Where am I on the XY axis? I'm in the 4th quadrant. And in the 4th quadrant, I go positive x-axis, negative y-axis, right? So my x value stays positive. This y value becomes negative. And then the hypotenuse is always positive. And this is how we create reference triangles, which in a later video, I will show you how we find trig functions. I hope this video was helpful, and thank you everyone so much for watching.